So now we are going for ray tracing. Everyone ready? Right? So first we are going to consider the case 1, first case, and we are tracing all these rays or we are drawing the ray diagram for a convex lens. Okay? Of course, it's an equiconvex lens, it's a thin lens, all the assumptions are already there. So when this object is at infinity, when the object is at infinity, the rays of light that is going to come will be parallel, right? So in that case, where do you obtain the image? So if the rays of light are coming as parallel, then after they pass through the lens, they are going to converge at a point, and this point is going to be where? This point is going to be your second principal focus, right? Okay. So where do you get the image in this case? You get the image at the focus. So the image is at the focus. Object is at infinity. Now, when I say infinity, you have to understand that I mean infinity in relative terms. Okay. For example, if you are looking at a lens which is having a focal length of, let us say, 10 centimeters. Okay. And if I talk about a tree which is located at a distance of 50 meters from that particular lens, well, that tree is nothing but at a distance of infinite length. So that object is at infinity. It's a relative term. All right. Okay. So this is what we mean when we say infinity. Now, the object is at infinity. So the image you are going to get at the focus. Next, what type of image you are getting? You have to see, are the rays actually meeting or do they appear to meet? In this case, they are actually meeting, right? So it is real. It is inverted. It is very, very small, right? So highly diminished. So nature of the image, location and nature of the image. Next, we'll just shift it, just keep it beyond 2f. Then what will happen? If you are keeping the object beyond 2f, again, you have to take two rays, one ray parallel to the principal axis, another ray, pass it through the optical center. Do it now, come on. What are you waiting for? Come on, do it. Do it, draw the diagram yourself. Okay, yes, drawn for this one. Now what will happen? You'll have two rays, one ray parallel to the principal axis will pass through the focus, another one from the optical center is going to pass undeviated. This is our optical center, of course, and you have an image over here. You have an image over here. And what is the location of the image? Well, it is between these 2 points, right? Which is between f and 2f. F and 2f. The image is real, it is inverted, and it is of small size, so diminished. Next, let's keep it at 2f itself. Let's bring the object at 2f. Then what happens? Again, we need to trace it by drawing the ray diagram. Let's draw the ray diagram. Again, two rays, one ray parallel to the principal axis, another one passing through the optical center, going undeviated. And what do you see in this case? You obtain the image exactly at this particular point, which is at 2f, right? So you are getting an image at 2f, image is real, it is inverted, and it is of the same size. Okay. Now remember that this is an equiconvex lens. So if this is f, this is also f, this is 2f, this is also 2f. Okay, fine. The values are equal. But you know that this is the second principal focus, this is the first principal focus, and these two are the center of curvatures. Okay, fine. Now, going ahead, let's take it between 2f and f. Let's see where we are obtaining the image. Again, we need to draw the ray diagram, and I'm sure you guys are drawing it with me. If you're not able to catch up, probably you can draw it later on also, no problem. Just understand that what is going on and how you are tracing. So as you can see that as the object started moving from infinity towards the lens, what do you see is going on with the image? The image starts moving from this focus to away from the lens, right? So as the object is moving towards the lens, the image is moving away from the lens, right? And you can also see that the size of this image also goes on increasing, correct? So when it was over here, when the image was formed at the focus, it was highly diminished or point size. Then we got between f and 2f, the size was slightly more, it was diminished, not point size, but diminished. As we move ahead, we came to 2f, we saw that the value of the image was exactly the same. The height of the image was exactly the same, right? The size of the image was exactly the same. And it was also formed at 2f. And when we are going beyond this, beyond 2f, what we obtain? The image we are getting it also beyond 2f. It is a real image. It is inverted and it is enlarged. Okay. So the size, as you see, goes on increasing, right? So the size is increasing. At this point, you're getting exactly the same size. And after that, it goes on increasing. So this is something that you need to, take away from ray diagrams. Now, let's move it further. Let's bring it to the next point, that is at F. And where do you obtain now? Well, you're going to obtain a real image at infinity. So at infinity, the image is real, it's inverted, it's highly enlarged. It's of a very large size, right? The next one is between the optical center, and the focus. Then, in that case, what you are getting? Well, in that case, you get a virtual image, a virtual enlarged image. So, a biconvex lens, and I'm only talking when the other medium is air, okay? So that is something, that's a disclaimer that you need to remember, okay? This medium is air. It always gives you a real image, except when the object is between focus and the optical center. In only that particular case, you get a virtual enlarged image. Clear with this? Okay. All right. So it is formed at the size of the object only. On this side itself, image is virtual, it is erect, and it is enlarged. So we have seen all the cases. How many? 1, 2, 3, 4, 5, and 6. So 6 cases for biconvex lens. Well, I'm sure all of you are capable enough to draw the ray diagrams for this. You have also done this in your lower classes maybe, right? And this is too simple. All you have to remember is that which rays you should take. And in all these cases, you can just take 2 rays and that will be sufficient. One ray which is parallel to the principal axis, another ray passing through the optical center. And the nature of the 2 rays already you know it, right? Next, talking about this concave lens. What happens in case of concave lens? Well, only 2 cases. First is if the object is at infinity, and second is that you place the object anywhere. Okay, you see, you'll have only 2 cases. First is when the object is at infinity, the image will be formed at the focus, and second is that when the object is anywhere, then what happens? First, when the object is at infinity, it is formed at the focus, it is a virtual image, it's erect, it's highly diminished, all that. Okay. And if you place any other location, if you place it at any other location, where do you obtain the image? You're always going to obtain the image between the focus and the optical center, and you're always going to obtain a virtual image. Always you're going to obtain a virtual image. All right. Did you get this? Okay. So only 2 situations. If it is anywhere else, you obtain the image between optical center and the focus. The image is virtual, it is erect, it is diminished. So a biconcave lens always gives you virtual image. No problem? You'll remember that? Okay, cool.